In this lesson, we are going to go through a couple examples of how to convert from rectangular form to polar form, which is kind of a trig look to it. So polar form, and we're going to specifically focus on complex numbers. So a rectangular form is x plus yi. This is your real, this is your non-real. Usually you would have seen it as like an a plus bi. I throw the x and the y in because that's how you would have graphed it. Treat that like your x, treat that like your y, and that's what your picture would have looked like. But we're going to take that and turn it into a trig form, a polar form, which is going to have a radius and it's going to have an angle measurement. And so the way it's going to look is the radius times cosine of your angle plus I sine of your angle. In short, you may see this cosine theta I sine theta abbreviated into CIS, so that's cosine I sine theta. Those angles are always going to match, and then times R. So here's what we got. We're going to use some of this information on the side that every time you have an x is going to be equal to r cosine of theta, y is going to be equal to r sine of theta, and the square root of x squared plus y squared equals r. Now you don't have to memorize that because you've actually been doing something related to that for a long time in a trig class. So it comes from the fact that when you were doing your unit circle, now this isn't a unit circle, this is just a circle with a radius of r, that you plot a point on that circle, and then you can build a little bit of a right triangle. In that right triangle, you can turn pieces of your x's and y's into trig pieces. So sine of theta would have equaled the y value divided by the radius. Cosine would have equaled the x value divided by the radius. And then those two are where these two come from. Because if I just multiply the r over, then I have y equal to r sine theta. It just comes from this. And then this, r cosine theta equals x, just comes from me multiplying the r over on this one. And then there is no r on this one, but on this one, it is the equation of a circle with a radius of we don't know. So x squared plus y squared equals r squared. If we square root both sides, we isolate the r, and so it's equal to that. So these are the rectangular version, and then these are the polar version, and those are the equivalencies to them. So there's a bunch of different ways to do this. I'm always a fan of a visual. Let's draw a picture on something like this. And so I'm going to take this and draw it. So if we draw this, remember that drawing a complex number this is like your x and this is like your y. So we'll go left 3 and then, I don't know, we'll say this is, so that's left 3 and we'll call that the negative 3i root 3. So this is your point. That's our vector. And what I want to do is draw a triangle to this. So on this triangle, we have a length of negative 3, and we have another length of negative 3 root 3. Don't throw in the I on this length, it'll definitely mess it up. So, so from here, this is meant to be a non-calculator. So if it's meant to be a non-calculator, we definitely are dealing with 30, 60, 90s or 45, 45, 90 types of triangles. And if you notice that this is a 3 and this is a 3 root 3, that's like the x root 3. So this is going to be twice whatever that is. It's part of your 30, 60, 90 triangle. So if you recognize it, you have an x, 2x, x root 3. That's the 30, that's the 60. So you're sitting at this being across from the 30, and that's your x. Double it for the hypotenuse, which puts that at a 6, which makes this 60. And the why I need all that information is because we need the r value. The r value is 6. We need our angle. Our reference angle is 60, but all the way around is going to be 180 plus the 60, which is going to be 240. So that's everything I need. So if I'm going to write it from here to here, all I'm going to write this is 6 cosine 240 plus I sine 240. And that is our polar trig version of it. All right, so if we do another one, actually we'll do another one in the next video. So we're going to do 2 more in the next video that relate to something like this. We'll draw 2 pictures again. One of them is going to be meant to be a calculator, and one of them is not going to be meant to be a calculator. So the calculator one, we have a little bit of a shortcut, but the non-calculator, we're going to draw a picture and we're going to figure some stuff out that way. All right. right, so we'll do another video for the next two.